Now we are going to look at a workshop for the application of a LRS to the tibia. Depending on the amount of length that is required, one should initially choose the length of rail that one is going to use. For a transport indication, the length of the rail should be almost as long as the tibia itself. I will be showing you now the use of 3 templates with the purpose of getting the pins as perpendicular as possible. We have 3 templates there. One of them, for purpose of demonstration, is a swivel clamp template, but one could well use all 3 templates for straight clamps. The first step is checking that through the holes one is able to reach the tibia at all levels. After appropriate incisions, pairs of 4.8 mm drill guides and 6 mm screw guides are inserted into both of the end clamps. Using a 4.8 mm drill, the first screw is inserted. Since this is going to be a transport, the rail has to be parallel to the long axis of the tibia. After the first screw is put in, one can rotate the frame around the first screw to ensure that the second screw, which is put through the last hole in the template, also passes through the center of the tibia in the distal portion. In this hole, one then puts in the appropriate length of tapered Schanz pin. With these 2 screws in, the templates now form a guide for the passage of the remaining Schanz screws. Normally, you would put in at least 3 Schanz pins in each of the clamps which are at the end, and the transporting fragment would do with 2. If necessary, 3 can also be used. Now, as you will see here, after all these screws have been put in, they are perfectly parallel to each other. This is something that is not usually possible when one does it freehand, and therefore it's highly recommended that one use templates to ensure parallel placement of the Schanz screws. Once the screws are in, it's just a matter of sliding the appropriate clamps onto each of those sets of screws, and a rail can then be threaded onto each of these clamps. In the workshop model, of course, we have used an intact tibia, but the same principle would be used for a fractured tibia which was stabilized with traction. The clamps are tightened to the rail, the first and the third clamp, and you put in a distractor in between clamp number 1 and 2. Depending on the distance between the clamps, one can either put it between the holes which are close to each other or the hole which is farther away. As you will see later, once the clamp starts moving and the distance between clamp number 1 and clamp number 2 increases, one can take out the distractor, close it down again, and put it into the closer hole of the central clamp. And that is what you will see being done here. It's reached the end of its length. Therefore, the central clamp is temporarily stabilized and its position changed. Once this is done, one can continue distraction, which then ultimately causes a compression at the original non-union site. Once the non-union site is under compression, the central transporting clamp is also locked. Later, once the regenerate is solidifying, to accelerate the process and to provide micromotion, one can place a dynamization block distal to the first clamp, loosen the first clamp, at which time the process of walking and weight bearing would cause micromotion at the regenerate site.